Right. So we have examples of algorithm. For example, just as I said, the algorithm is step by step of solving a problem. Now we have examples of algorithm. Number one, an algorithm is an algorithm to calculate average of three numbers. An algorithm to calculate average of three numbers. How do you do that? So if you want to write an algorithm to calculate average number of three, so you need to follow a certain procedure. You need to follow a certain procedure. So now, for example, you have this. What is the three number? The three number is unknown. The three number is unknown. So what we are going to do now is, you can just name the first number. Okay. Let the first number be n1. Am I communicating? Since the number is not unknown, the question says an algorithm to calculate average number of average of three numbers. So we say let the first one be n, then the second one to be n2, where the third one is n3. So these are the steps, the procedure that we take in order to find the average number of 3. So of course, so you now have what again? So now that you have n1, n2, n3, what we now do, you need to do what? You need to add. So you do the word addition to find the average number. You add the three number. Okay, you add. So what you do now is that you add the three numbers together, which will give you, let's say this is the first step. Step 1, step 2, step 3, step 4. Then this, you add all the value that you have, n1 plus n2 plus n3. Am I communicating? Because said to calculate the average number of three number. So in other words, so step 5 now, what we do is to do what? To find the average. You find the average of the three number, which are n1 plus n2 plus n3. What will be the average? Divided by what? 1, 2, 3. So you have 3 divided by 3, and then what? You have your total result. Step 4. First of all, you have the total result of your addition. The total result of addition. Total result of addition. Total result of you have total result of addition. Then 7, then you have total of average. You have total average. And step 8, then you print your what? You print your results. You do what? You print your results. So you can see the steps and the procedure we takes in solving the problem. It says calculate the average number or the average of three number, which is unknown. So we just assume that okay, since it's three number, we just give it a name. Let it be maybe n1, n2, n2. So since because I use n1, n2, n3 doesn't mean that you can't use any other alphabet. Am I communicating? I'm just using this alphabet to represent the number since it's not given. Then 9, you do what? You end the program. You do what? You end the program. So now let's take a look at another example. Then we'll be able to dwell a lot more about flowchart when this topic is concerned. So the flowchart, example 2. Oh, let me rub off the board. Example 2. Print what?
To play.
Print out the first 10 numbers. Print out the first 10 odd numbers. Odd number. Pause.
Split.
Alright, so question 2, print out the first 10 odd number. Print out the first 10 odd number. How can you print out the first 10 odd number? You know, to print out the first 10 number is very easy. That's why I said algorithm is a step-by-step of solving a problem. And meanwhile, remember, if you are using a program like QBasic, in your compiler you already have a default interface where you can actually do what, write your program. But in this case, you are just making use of a board. So I'm going to do it in form of like you are using a program. So for step 1, so all this number will be there in default. For step 1, you can just say that assign is 0 to p. Mind you, I'm picking p. You might decide to, I'm just using p as an example. You might decide to use any number of your choice. Am I communicating? You might decide to use, So since we are to print out the first 10 odd number, am I communicating? And okay, let's say we are starting from 0. So when you assign 0 to p, it shows that p is what? Is 0. Am I communicating? Showing G. Alright. Okay. So step 2. Alright. So step 2, you do what? You assign that same 0 to counter. You assign that same 0 to counter, which means at this point, if p is stored inside counter, then p is 0. Remember last session, I think we do register when we talked about type of register. We have program counter, we have accumulator and all that. So if you are saving a 0 inside p, definitely if you are assigning any 0 to counter, it shows that at this point p is 0. Am I communicating? Then 3. Alright. You had what? You had 1 to counter. You add 1 to what? To counter. You add 1. So by adding 1 to counter, it shows that you have given another value to p. The value of your p will change. Then you do what? You print p. So if you are printing p here now, p will be what? 1. Because you have do what? Add 1 to counter. And p is stored in counter. Am I communicating? P is do what? Stored in counter. So if you are adding 1 to this side, so it shows that that p is now 1. Am I communicating? So you do it. Yes, alright. Any question at this point in time? Okay. Alright. So p is 1. So you now move to the next step. Now, of course, all this number is by default. If you are using system, when you move to the next line, it will keep giving you another number. Then you do what? You add what? 2 to p. So you are adding 2 to p. Then you have, if you are adding 2 to p, which means that this is p. If you print p here is 1. Here now, if you are adding 2 to p, p will now be what? 3. Am I communicating? P will now be what? 3. Then step 5. Let's use decision symbol that says is counter greater or equals to 20. Is counter greater or equals to 20? Then okay. Is counter greater or equals to 20? If no, go to step 3. Yeah. Then you do what? You stop your program. Let me quickly explain this slide for you. Add 2 to counter. Okay. If no, go to step 3. For example, let me rephrase. No, step 4, we have add 2 to P. So if you're adding 2 to P, if you print P here and P is 1, then if you're adding 2 to P here, then P will be 3. Then step 3 is counter greater or equals to 20. By the time that you get here, you know that P is 3 and P is stored inside counter. Definitely at this time, counter is 3. Definitely the answer is no. So if it is no, you do what? You loop. You go back to step 3. You loop, it means that you do what? You go back to step 3. So by going back to step 3, you do what? You add 2. You do what? You repeat the same step. You do what? You repeat the same step. So at this point, by going back to step 3, if you print P at this point it will now be 3. Am I communicating? So step 4, if you add 2 to P again, P will now be what? 5. Then step 5 now say is counter greater or less than greater or equals to 20. If no, go to step 3. You loop again, it will come back here. You now do what? You print P. At this point, P will now be 5 because remember P is already 5 here. So if you are now adding 2 to P again, at this point again, P will be 7. Then is counter greater or equals to 20? If no, go to step 3. So at this point, you go and loop again. Then if you are printing P, it will be 7. Then step 4, add 2 to P, then it will be 9. If you are adding 2 to P, then it goes like that again. So if it is not up to this, then you go back, you keep moving until you have 19, because the question says print out the first 10 odd number. Then after you get to that point, then your program will do what? You will stop. Any question at this point? Any question? Okay, in the absence of no question, I believe you enjoyed this tutorial. Please leave your comment below and don't forget to subscribe to my channel. Oh, are you guessing? Don't forget to subscribe to my channel. I love you all and I've missed you. Please make sure you drop down your comments.